Hello everyone, myself Dr. N. Gopinath, Assistant Professor from the Department of Computational Intelligence, SRM Institute of Science and Technology, Katangalathur campus. Now we are going to see about Unit 3, the concepts of routing. First, let us start with forwarding of IP packets topic. IP forwarding is a process of sending a packet from the source host to the destination host across multiple networks. Routers play a crucial role in forwarding by examining the destination IP address and deciding the next hop. Direct versus indirect delivery. Direct delivery: when the destination is in the same network, the packet is delivered directly without a router. Whereas indirect delivery, the packet must be forwarded through one or more routers. Next, role of routers in forwarding. Routers use destination IP address, that is from packet header, routing table which contains next hop information, and the third one is forwarding decision, which is used to choose the best route based on the prefix matching. And this is the routing table structure, which normally contains the entry like the destination network address, subnet mask or prefix length, next hop, that is router IP, interface, that is the exit port, and finally the metric, that is the cost of route. Forwarding process is explained step by step. First one, it receives the packet. Step 2, extract destination IP address. Step 3, match against routing table entries. Step 4, identify next hop and outgoing interface. Step 5, update packet headers. And step 6 is finally forward the packet to the next hop. So these were the step-by-step procedures which are happening in the forwarding process. Next is the longest prefix matching. It is shortly called as LPM. It is the method routers used to select the most specific route for a destination IP. A prefix is defined by an IP address along with the subnet mask, that is CIDR notation. The longer the prefix, the more specific the match. Example given here. Suppose the destination host IP address is 192.168.1.25. So from the routing table, 192.168.0.0 to 16 is found to be a router A. Similarly, 192.168.1.0 to 24 is considered to be router B. So, router B is chosen for forwarding the packet. Forwarding versus routing. First of all, we should know the simple difference between two different processes. One is routing, another one but learning the paths. Whereas forwarding is sending packets using routing table. Next, we will see about the challenges in IP forwarding. The first challenge is large routing tables. Second one is high-speed processing needed for gigabits or terabit links. Third one is fragmentation, if packet is greater than maximum transmission unit. And the last one is the security issues. The next topic what we are going to see is about static and default routing. Routing is typically of three types, each serving its purpose and offering different functionalities. So the types of routings are static routing, dynamic routing and default routing. First we will start with static routing. Static routing is also called as non-adaptive routing. In this, routing configuration is done manually by the network administrator. Let us say, for example, we have 5 different routes to transit data from one node to another. So, the network administrator will have to manually enter the routing information by assessing all the routes. So, here the configuration of static routing is shown here. Here we are using router R1, R2 and so on. Configuration of static routing. So from the previous slide picture, the summary is given here. R1 is directly connected to 192.168.20.0 to 24. And similarly, R2, that is router 2, is directly connected to 192.168.10.0 to 24. And R3 is directly connected to 10.10.10.0/24. So routers are connected to each other via 172.16.10.x/30. Configuration of static routing, that is static routing on R3. So here the explanation is R3 does not know about the networks connected to R1 and R2. So we configure the routes which are given here. Next, the static routes on R2. R2 already knows about directly connected with the IP address 192.168.10.0/24. And similarly for R1 already knows that it is directly through the IP 192.168.20.0/24. So the overall packet flow example. Let us say a host in 192.168.20.0/24, that is behind R1, wants to send a packet to R2. So host sends to R1, R1 forwards to R3, R3 forwards the same to R2, and R2 delivers to host in 192.168.10.24. And the second one, a host which is lying behind R2 wants to send a packet to R3. So the host sends to R2, R2 forwards directly to R3, and R3 delivers to its host machine. Default routing, that is the second type of routing. This is a method where the router is configured to send all packets toward a single router. It doesn't matter to which network the packet belongs. It is forwarded out to the router which is configured for default routing. It is generally used with stub routers. A stub router is a router that has only one route to reach all other networks. So here is the diagrammatic representation of the default routing method. And its configurations, as usual, what we have seen for the static routing is given. So the packet flow example for default route. Suppose the host in R1 LAN wants to send a packet to the host in R2 LAN. So the procedures are: packet reaches R1, R1 checks its routing table and there is no entry. Then the default route sends packet to R3, R3 forwards the packet to R2, and R2 delivers to the destination hosts. Similarly, the host in R2's LAN wants to send a packet to host in R3 LAN. So, as usual, the packet reaches R2. There is no entry in IP with 10.10.10.0. So, the default route sends packet to R3 and R3 delivers directly to its own LAN. This shows how the default routing reduces the time taken for transmitting the data. Next topic is unicast routing. Unicast means the transmission from a single sender to a single receiver. It is a point-to-point communication between the sender and receiver. There are various unicast protocols such as TCP, HTTP, etc. TCP stands for Transmission Control Protocol. This is the most commonly used unicast protocol. It is a connection-oriented protocol that relies on acknowledgement from the receiver side. HTTP stands for Hypertext Transfer Protocol. It is an object-oriented protocol for communication. Next, major protocols of unicast routing. The first one is distance vector routing. It uses a distributed algorithm to compute the routing table. Second one is the link state routing. It uses link state routers to exchange messages. that allow each router to learn the entire network topology. And the third one is the path vector routing that maintains the path and it is dynamic in nature. First, we will move on to the distance vector routing algorithm. It chooses the optimal path for data to travel between nodes is the distance vector routing. It works by exchanging data with its nearby nodes that are directly linked in order to compile a table of the most direct paths to every other nodes in the network. Every node in the network keeps a routing table that details the distance to each target node as well as a subsequent hop node on the way there. How does DVR protocol work? Distance vector routing protocol is a routing algorithm used in networks to determine the best path for data packets to reach that destination. So the operations are listed here. Routing table, information exchange, distance calculation, path selection, updates and loops, simple and scalable. So here is a simple example given for distance vector routing. Consider the following network. Three routers are there, A, B and C, with AB equal to 1, BC equal to 2 and CA equal to 5. Let us see the following steps to understand it better. Each router share its routing table with every neighbor in the distance vector routing, as A will share its routing table with neighbor B and C. Neighbors B and C will share the routing table with A. So here is the table for each and every router A, B and C. If the path via a neighbor has a lower cost, the router updates its local table to forward packets to the neighbor. In this table, router A will be updated. The following is a final routing table for all the routers A, B and C with lower cost distance vector routing protocol. Three keys to understand the working of distance vector routing: distance metric, routing table and Bellman-Ford algorithm. So as of now we have seen about the introduction of the routing, followed by the types of routing, that is static, dynamic routing, and then we have seen about the concepts of unicast routing. Under this unicast routing we have seen about what is TCP and what is HTTP and the major protocols which are contributing to the unicast routings like distance vector routing, link state routing and path vector routing. So from the upcoming slides we are going to see in detail about some other different concepts which are coming under the computer network subjects. Thank you.